Here we are going to show a rule that we should be familiar with from algebra using techniques from calculus. Example 16.7 asks us to show that the natural log of b times x is equal to the natural log of x plus the natural log of b. And we're going to use a corollary of the mean value theorem, which states if we have two functions, f and g, and we know that their derivatives are equal to each other, then that means these two functions must be changing at the same rate. So if this is f, then g has to do the same thing. It might be just shifted up or down, but it changes at the same rate. So if f prime is equal to g prime, this implies that f is the same thing as g, just plus a constant or minus a constant, right? A shifted version of each other. So let's work on this. We will show that the natural log of bx and the natural log of x have the same derivative, thus change at the same rate, thus they differ by this constant. So we'll take natural log of bx and we'll take natural log of x, and we will differentiate both of them and show that we get the same thing. On the left-hand side, we have 1 over bx times b by the chain rule, and on the right-hand side, we have the derivative of the natural log, which is 1 over x. And with a little bit of simplification, we find that 1 over x is indeed equal to 1 over x. Therefore, natural log bx, natural log bx changes at the same rate as natural log of x. Their derivatives are equal to each other. And by the corollary of the mean value theorem, that means these two functions differ by a constant. So we can just rearrange this and solve for that c value by taking natural log of bx minus natural log of x. Now, if this is supposed to be true for all x values, this function is just a shifted version of that function for all x values, then it should hold true when x is equal to 1. So if we look at x is equal to 1, we see that the c value is natural log of b minus natural log of 1, but the natural log of 1 is 0. So the c value that we're missing is the natural log of b. So the c value that we're missing is the natural log of b. And we've shown what we wanted to show. So the natural log of bx is equal to c, which was the natural log of b, plus natural log of x. And this concludes the proof.